Now we're going to look at multiple events. The idea of multiple events is that you're still going to have to deal with AND, which is the probability of one times the probability of the other. Then there's addition. Addition is applied when it's a situation of OR. So probability of one or the other minus the probability of both. Keep in mind that for AND you multiply and for OR you add. It's just kind of helpful to remember the two. So these formulas are good to keep in mind always. With multiple events, that means you're doing the probability more than once. So you're choosing once and either replacing or without placing. With replacement means we take the item and then we put it back in order to do the probability next time. And so everything's back, so you do the next probability. Without replacement means you go to take an item out and then it's actually like gone. It's not considered when you do the next probability. In a case of without replacement, you have less items on your next probability as a total, so your denominator is different. Now consider the probability of choosing two blue items. That's the probability of blue times the probability of blue again, but this time there's one less item. Notice there's one less blue making it 7 over one less total making that 14, so it's 56 over 21 when you multiply the numerators and the denominators, which can be simplified to 4/15 and just get simplified to decimals or percentages. Now let's look at the idea of finding the probability without replacement again of two rectangles. So the first one's a rectangle is 10 out of 15, but the second one being a rectangle, you have one less, so it's 9 out of 14. And they're just rectangles, so it's not like there's any difference one way or the other. That's how I reduce it to 3/7. Now if I look at a circle and a rectangle, now that means I could get a circle and then a rectangle, or a rectangle and then a circle. So the order in there could be different. So I'm going to find the probability of a circle times the probability of a rectangle. And then my OR, considering the backward situation, I'll do the probability of a rectangle times the probability of a circle. Now those fractions are 5/15 times 10 out of 14, because there's one less considering without replacement, or 10 out of 15 times 5 out of 14. Simplify each fraction by multiplying numerators and denominators, and you end up with 100 over 210, which can be reduced to 10 out of 21. Now we're going to consider the following, where you have two separate events. Which of the following has the greatest chance to occur when you have a spinner and a die? The probability of A and 3, or the probability of A or 3? Well, the probability of A and 3, you just multiply the two because it's and you multiply, giving you 1 over 18, and that's a very small number. But this one with OR is an addition going on. So that's the probability of A plus the probability of 3 minus the probability of both, which is not possible. So that's probability of A is 1/3, 1/6, minus both is not possible, so I got a common denominator. I know you guys can just put this in your calculator, and you end up with 1/2, because 3/6 is 1/2. What about the probability of A, and we keep the OR situation, but this time we do even. That would be the probability of A plus, because it's OR, the probability of an even minus the probability of both being A and even, which is pretty much 0, because that's not possible. So the probability of A is 1/3. The probability of even, now that is 2, 4, and 6. So that would be 3 out of 6 minus 0 out of 6. So then you need a common denominator and multiply these by 2. So that's 2 over 6 plus 3 over 6, which equals 5 over 6. Wow, those are good odds.